Okay, now we will prepare our acid for acid demineralization. So we will prepare about 1 molar of 8 liters volume. So because this acid is fuming, so we need to make sure our fume hood is on lah. So we need to switch on the pump. Okay. And then the way how to prepare the acid is basically adding the acid to the water, not the other way around. The reason being is because the reaction is exothermic. If you add water to the acid, there will be a risk of splashing and boiling. So the best practice, the good practice is just to add acid to the water in order to dilute the thing. So now we prepare 2 liters of water here, and then we will put these 2 liters into this our PP container. Okay. Okay, so we put that first. Okay, now this 2 liters, our working volume, remember, is 8 liters. So now we will put this container into this overhead stirrer. Okay, so now we will prepare the acid. In order to make 1 molar of 8 liter acid, alkali acid, so we need to measure 657. Okay. Okay, so that is 500 first, and then we add acid to the water. And then we measure an additional 157. And now because we already use, we can close this first. Okay. And because we already use 657 of acid here, plus with 2 liters of distilled water at the beginning, so we already have 2.65 liters of solution here. So in order to make it 8 liter solution, we need to add 5 liters, 5.35 liters distilled water to this. Okay. Okay, so the working volume is already 8 liters. So now we will on our overhead stirrer. So we set our stirrer to rotate at 400 RPM. Okay, now we will weigh our chitin sample. We only need 200 gram. Okay, and then we can pour it into our acid. But we need to make sure we pour it slowly. We can take a spatula first. Maybe take a spatula. Because the acid will react with this calcium carbonate, because the mineral on the crab shell is calcium carbonate. The acid will react with this calcium carbonate, and that will release carbon dioxide, and you will see like the bubble will form. Okay, so we sprinkle a little like that. Okay. Okay, you can see that the bubble is forming. that is basically carbon dioxide. It's formed due to the reaction between the acid, HCl, and also calcium carbonate in the crab shell. And that's why it's important for us to use like high heat of the container, so that when the bubble form will not reach to the top. And also we make sure our paddle there is positioned at the surface, so it's good because it can act as a what I call the foam breaker lah. We stop for a while. So if you look here in our sort of like in our, there are like another half remaining, but you can see the bubble there is already keep rising. So we wait for a while. We wait what we call until it settle down, until it break and settle down for a while. To help breaking the foam, we can also use the help of wooden spatula there. Okay. And then we can add our remaining crab sample there. And also it's important for you to prepare the tissue here, because the spatula there is already deep within the acid, so it's help to prevent the acid from splashing lah. And then we add our remaining sample. And then we can take our spatula, wooden spatula, to help breaking the foam further. For acid demineralization, we only need 30-minute period, but we will start the timer once the foam is settled down, most of the foam settled down, because when you have foam here, it's basically bringing up the what I call the sample together. So you can see the foam is sort of like going up like that. So that's why it's important for you to have this height of the container, or else the foam will be splashed out lah. So this we can just wait for a while. It will go down, but it takes time lah. It's important to start the reaction when the bubble or settle down, because the bubble itself, can you scoop a little bit bubble? You can see the bubble itself brings some of the what you call of the crab sample, the crab shell sample. So we need to make sure all this bubble settle down before we can start the timer lah. Okay. As you can see here, there are a lot of crab shell sample that is what you call adhere to the surface of the inner bucket here, because when the bubble come up, the foam come up, so it will bring also along the crab shell. So we can clean this thing by using the distilled water. Of course, this will add the total volume, but because we just use very little water, so it's okay. So you can see now that is the condition after around maybe 5 minutes of stirring with the spatula. Okay. Okay, so here you can see our blade on the surface of the solution. This is good at the beginning because it helps to break the foam. But now we want to lift down this thing down, so that we can easily stir the remaining bubble on the surface of this liquid. So we close the first, and then we lower down our overhead stirrer, so that it will be in the middle of the solution there. And then we on back, and now now the advantage now is that you can see the water will bring in the what we call the bubble in. So now we can use our spatula to help immerse all the remaining bubble. Because remember, on the bubble there might be some of the crab shell powder or sample, so we want to use all that. Okay, so from the beginning until now, it takes about 10 minutes, I think, from the when we start adding the crab shell, and then the foaming happen, and we break the foam, and then we lift down the sting. All that takes around like 10 minutes to 15 minutes like that. So now it's look okay to start the timer, the 30-minute timer. For the acid demineralization, we only use short time because we don't want to depolymerize our chitin. Okay, longer time will depolymerize our chitin chain, and also we don't do it in any heating, just at room temperature. So we can start now. Okay, and then after 30 minutes we will take back. Okay, it's already 30 minutes after we subject our crab shell to demineralization process. So that is the consistency after 30 minutes. So there are not much bubble there. So we can stop this. Okay, so this thing we can bring down and bring this to acid and bring this to what we call the filtration setup. Okay, so that's 8 liters of our acid sample. You need to be careful here. So we pour everything. So here it's okay we do it outside the fume hood, because 1 molar acid at room temperature doesn't produce a lot of vapor lah. But if you use concentrated acid like from the stock, then you need to use it in the fume hood. So here we don't use any pump, but the gravity alone is enough lah. So that is how we filtrate the remaining acid. So we want to get only the what we call the extracted not chitin but demineralized crab shell. Okay, after we done adding all our acid extract, what we will do is that we will stir it with the ladle to improve what we call the filtration, because some of what we call our chitin powder that's already demineralized may be stuck on the surface of the bottom of this what we call of this filter close, so it's block the pore. So we need to open the pore like that. Okay. Okay, we use tap water to neutralize our acid extract. We just add like that. And for crab sample, what I call the filtrate will goes down much more easily lah, compared to if you extract chitin from fungus or mushroom. Okay. Okay, so this is how many liters already? 16. So it's already 16 liters added to our extract. So now we want to test what we call the pH of this volume. So just dip like that, and then you can see there is around, it's already more or less what I call neutral. So let me see very clearly. Yeah, it's already neutral there. So we can say that 16 liter or 20 liter is more than enough for a crab sample to neutralize from acid to neutral. Okay, we use our spray to remove any remaining residue of demineralized crab shell on the side of our filter close, so that we can get everything to be neutralized evenly and homogeneously. Okay, because we already know this is neutral, then the last step is to add our distilled water in order to rinse this thing off lah. So we use distilled water. How much we use is just to fill up all this thing lah. Okay, one thing that we need to be careful is that we need to make sure that the water there doesn't fill up, doesn't reach to the tip of our bunch of funnel there. So this is still, there are still some clearance. Okay, so all this is already neutral, so it's not really a problem now. So we can pour this inside any bucket or whatever. And then we can continue putting back our filter close to this perspective, and then we can continue stir it. So this will be our last spray, and after this we just straight away scrap all this demineralized crab powder on the table. So this is a final texture of our demineralized sample after neutralization. We want to store this in the fridge so that we can use it later. Because we already neutralize it, so it's okay. There are no reaction happen, no acid adhere to this sample. So we can store it and we will use it for hot water extraction and also alkali extraction later. Okay, but if you have time, you can straight away subject this to hot water extraction and alkaline deproteinization. But now, because we want to use it later, we will store this first in the fridge. So we just take the entire filter close like that, and then we lay down on the table. We open the filter close. And then we get ready with our scraper and also our container. So we can scrap this. So it's good if you have a spatula because it will make your life easier. And this is the last bit of our demineralized crab shell. Now we will store this in the fridge for future use. To start hot water extraction, we first take our chitin demineralized crab chitin sample from the fridge, and then because we will use 8 liters volume of water for this purpose, so we need to prepare in advance our distilled water. So here is 10 liters, so it's enough for 8 liters lah. So we will use our what we call this jug, blender jug, as a measuring cup. So that is 2 liters. And then we add our demineralized sample. Because it's quite viscous, it's good if we have a spatula ready. And then for the remaining residue here, what we can do is that we can add some water and from the from this distilled water, and we try to sort of like dissolve, not dissolve, but suspend this. But we need to measure first, measure 2000, so that we know at the end of the day this should be like 8 liters of distilled water. So we put maybe half there, half, and then we close this. We take out our spatula and close the thing, and we can shake it. So that will ease our removal of residual demineralized chitin on the surface of the container here. And then lastly, we can just top up our distilled water, so that the entire this pot will receive 8 liters of distilled water together with the our demineralized crab shell. Okay, so now we have 8 liters of working volume here, and then now we will bring this for heating and stirring. Okay, because we need to heat and also stir this thing, we need to use first, for heating purpose, we need to use this what we call hot plate. Okay, can you open first? Okay, normally for small volume like this is enough for us using this magnetic stirring bar. So we will show you first how we should put it. So we take out this what we call beaker first, because if you put the magnetic stirring bar while the beaker here, the magnet here, because there are magnet here, they will sort of like goes down and might break the beaker. So we take the beaker out and we put the stirring bar slowly, and then only then we put on the magnetic stirring plate. Okay, so this what we call this hot plate come with the stirring capacity, so you can just stir like that. So for the small volume, like maybe 2 liters like that, the steering bar can give enough vortex for the steering to happen efficiently. But if you have big volume like this, this is about 8 liters volume of solution. So it might be not sufficient to use this small steering bar. Even though it can, it might give some vortex, but the steering is not will be efficient compared to if you use this overhead stirrer. So we have overhead stirrer here. So the overhead stirrer here, we have this pedal like pattern steering pad. So we will use this to create the tangential mixing flow, and in order to sort of like start our hot water extraction, not only we need the steering, we also need the heating. So here the heating plate here have sort of like the height of this, and of course the maximum of our overhead stirrer is only up to here. So we need to make sure your what we call your pot have enough clearance. For example, when you put this pot on top of this steering plate, you need to make sure everything must fit, and so that it doesn't goes up to here lah. Okay, so we need to also make sure that our base of our pot must be clean, must be clean, because if there is any sort of like residue, then the contact between this steering plate and the pot will be not perfect, and that will cause some problem during the heating. And now we will put in our what we call our temperature probe. For hot water extraction, we need 85, but for this, we just ram it up for like say 100 like that. 100. The reason why we increase what we call the heat until 112 or whatever high temperature, because we want to speed up the heating, because this is quite a large volume of sample, so it will take time. If we put what we call on the dot 85 degrees Celsius, which is our intended temperature for hot water extraction, what will happen is that when it nearing 85, it will sort of like shut down and then heating again, and it will take a long time for it to reach 85. So we will ramp up to, like say, 100 like that, so that when it reach 85 later on, we will what we call lower down the temperature to 85. But if you use this method, you need to make sure that you take into account, you always need to observe this temperature, because you don't want this thing happen, this thing goes up to 100 anyway. So we need to make sure when it near 85 or when it reach 85, you need to stop, not stop, but basically run down this what we call this knob, so that the temperature that is 85. But for time being, we go 120 or like that, and then we can start our what I call stirring using this overhead stirrer. So we use 400 rotation per minute in this case. So as you can see, it's the now. And we will start our timer. So we will use what we call 1 hour. So for hot water extraction, we will use 1 hour duration, but we only start this only when this thing reach 85 degrees Celsius. Now the temperature shows 84.6 Celsius, which is a good time for us to turn down the temperature set here. So we turn down to 80, maybe 86 like that. Okay, 86, so that it can go to 85 much easily. So 86 is okay. So let's see how long it take for this much of volume, 8 liters of volume, to be heated from ambient temperature, room temperature, to 85 like that. So here we note something. So we start our heating at 8:40 AM. So now it's around 9:48. So now is 9:48 AM. So it take around 1 hour for us to heat up this thing, 8 liter volume of sample from room temperature to 85 degrees Celsius. And now we can start this timer. It's already 1 hour since we perform our hot water extraction at 85 degree. But if you look here, even though we put 86, the temperature shown here is 80.6 Celsius. The reason being because first, this is quite a big volume, but 80 is okay for our purpose. It's not really problematic. As long as it's hot enough, then it's good. So the purpose of this hot water extraction is to remove any dissolved salt or dissolved material that adhere to our demineralized crab shell. And also during the acid demineralization, the chlorine from the HCl might react with the calcium carbonate, calcium from the calcium carbonate of the mineral shell. Then they will combine, become calcium chloride. So by using this hot water extraction, we basically try to dissolve it further lah. So now we can stop the reaction. And then we will bring this for filtration before we subject this to hot alkali extraction. So we already prepare our what we call our filter setup here. Then we pour our hot water extract to this filter. So we hold a little bit. Okay, so you can see there are a lot of our sample over there. So we let it to be goes down for a while, so that we have a lot of volume to work with. And then later on we can just pour in one go, because if we pour slowly to this, then this thing will deposit on the what we call on this what we call the pot. So in order to make sure we remove everything, we just throw it faster lah. So that's why we wait for a while until it goes down, and then we can pour quite fast here. Okay. So for the remaining here, maybe we can use some water to remove the thing. The purpose for this is just to remove all the water before we add the alkali. So as you can see here, the filtrate goes down very fast. Okay, so we not even open our pump, so it's already already filtered down. So now what we can do is that we will wash this with the distilled water. After we filtrate with the distilled water, so this texture of our our sample after acid demineralization. So we will scrap this and put in our pot before we pour the alkali in. So we will lay down our filter close on the table to make it easy for us to scrap all the sample. So we get ready with this, what we call the scraper here, and also some spatula. So we just scrape it and we put inside this pot. Okay, so this our sample in the pot. So we'll top up with alkali later on. Now we prepare our alkali solution, 1 molar alkali solution for 8 liters. So we need 40 times 8 is basically 320 gram of pellet, and then we dissolve it in the 8 liter of water lah. So we first measure the 320 gram of pellet first. We use our beaker there. Okay, so it's okay, it's plus minus 320, 330 is okay. And then we put our beaker to the side. And because we need to add alkali to the water, we prepare our water first. So this is 2 liters mark. So we prepare 2 liters of water, and then we put inside this, what we call, pot. And then only then we add the alkali to the water. The reason being is because the reaction between alkali and water is basically exothermic. It's release heat. So if we add water to the alkali, then there will be a risk of splashing, okay, splashing or boiling. So that's the best practice, is to add water first, and then we can add our alkali to this water. And then we stir this alkali so that all the pellet will be dissolved. So the agitation might take around like 2 to 5 minutes to make sure all the pellets to be dissolved. It's already 5 minutes, so all the alkali is already dissolved. So now it's time for us to stop the stirring and pour this alkali to our sample. We just put our sample at the bottom here, so it's much more easier for us to pour all our alkali to the sample. So now we will continue with alkaline deproteinization. We need to make sure that this thing must be in the middle of this the hot plate. We need to make sure that we tighten it give a very good tight here, because this overhead stirrer is quite heavy. So we don't want during the stirring this thing will flip down. and we position our overhead stirrer to the middle, and then we will put our what I call temperature probe. So here we will set it to 65 degrees Celsius. It will take about 30 minutes in order for this from room temperature goes to 65 degrees Celsius. But as usual, we will ramp it up maybe to 100. Okay, and then we need to make sure that when it's near, it's too much. We just 100 is okay. Okay, so we make sure that when it reaches 64, 65 ish like that, we need to ramp it down to 65. So now we will on our stirrer. So this probe, we need to put it in such a way that it not in the vortex. So it must be not in the vortex place. Must be a little bit farther than that, but not touching the what you call the edge of the our pot, so that it will give you the accurate measurement of temperature for the whole thing lah. So we will start our what you call our 3 hours. So for alkaline deproteinization step, we will do it in 1 molar alkali solution and EOH solution for 3 hours. But we only start this 3 hours timer after this reach 65. It's already 3 hours since we subject our sample to hot alkali deproteinization. So this is the consistency of our sample. So remember, the sample already undergo the acid demineralization and also hot water extraction, and now is already after 3 hours of alkali deproteinization. So we can say it's already finished, and we will filter this out. Okay, here we already set up our filtration pump and also the filtration close. So this is our sample. So we will pour slowly to this filtration close. Okay, we wait for a while until this level goes down before we pour the remaining here. It's good if we have this ready, because later on at the end of the pouring, there might be some leftover residue on the surface of this pot. So it's good if you have this ready lah. Make sure you pour this carefully, because if not, this is alkali, and then if you rush, then it will what we call spill over this. So you need to do it slowly and carefully. So as you can see there, without what we call without on our vacuum pump, the what we call the filtrate goes down quite fast there over there. Now, in order to fasten this, we can also on the pump. Okay, by using pump, you will fasten the filtration process significantly. Okay, just like that, you got this chitin cake residue on the top of the filter close. So now this is still alkaline. So we will add water, tap water, and keep top up on this filter close until the what I call the pH is neutral. We can use this pH strip to check whether the pH become neutral or not. So now we will add water. It's good also for you to sort of like use this wooden spatula to sort of like make the residue become homogeneously immersed in the tap water. Okay, one thing that you need to be careful when using this what I call filtration pump is that to make sure when you do the filtrate will not go up to the funnel there. So now you can see there, the funnel is already what we call immersed by the filtrate, which is not good lah. So luckily we observe this before we pour another tap water. So what we do is that we stop the pump first, and then we will take this thing out lah. So this already 8 liters plus another 8 liters of water. So the first 8 liters is from the alkali, hot alkali extraction, and then we top up another 8 liter. So total now we have 18 liter here. And here how we check whether this there are some suction or not, because this pump doesn't have any gauge. So if you can feel some like suction, then we can say that the suction is good lah for this purpose. And then we add this on top of that. And then after this we just continue top up until it neutral. So in order to know the pH of our sample, we will use this what we call the pH strip. So we just take the pH strip, and then while it become like this, we sort of like stir it first in order to get a good representative of all the sample within this filter close. And then after it's homogenized, what we do is that we take this thing, we just dip like that, okay, and then we look here. So here is already what we call, it's already near, it's already, I think it's already sort of like neutral. Okay, so maybe we can check one more. Maybe we can add further water, and then we sort of like stir this like this, and then okay, maybe enough. Can you help stir vigorously? So we want to see, and then we want to take this. Okay, let it. Okay, so let me check. Okay, just like that, and then we see. So this, the color is already 7 lah. So it's already neutral. In this case, it's already neutral. So we basically already use around, maybe we can finish this off. So basically, we use around 8 plus 8, 16 liter water. 16 liter water in order to make this our sample neutral from the alkali hot extraction. So after this, we wait the water to go down, okay, and then maybe we can rinse the what we call the side of the filter close with the spray like this spray. And then because this is already neutral, what we'll do after this is that we will rinse with the distilled water. How much we rinse is just maybe just to fill up this filter buncher funnel, then it's more than enough lah, because we already know this thing is already neutral. So we make sure our distilled water ready over there, and then we will start rinsing this thing. So we just fill up the distilled water until it fill the entire what I call the entire buncher funnel here. So while doing that, it's good idea for you to stir this so that you will make sure that everything is exposed to this distilled water lah. Okay, I think this is enough for the rinsing part. So we wait until this distilled water run down, and then you get the chitin. Okay, so this is our crab shell chitin consistency after we done with neutralization and also rinsing with the what we call with the distilled water. So as you can see, this is the chitin that we got. So now what we will do is that we will store this in a container. So we close this thing first, our pump, and then we take our sample and bring it to the table. So we will lay down our filter close on the table for us to easy scoop it and put it in our container. But first, this container, we need to measure the weight for this container, so that later on, based on dry weight, we will know how much chitin actually is inside this. Although this is chitin, but remember, this is also mixed with some water, so there are some dry weight there. So we need to weight this our what we call our container first. Okay, so it's around 56 gram, and then we can just stir it. And then we will put our chitin inside this. For this container, we already we already sprayed with our ethanol 70% before we weight it on the balance, because we want to store this for quite a time. So we want to make sure the inside of this container is already clean lah from microbes and whatever. So now we will scoop this and put it into the container. Okay, because this chitin is not really dry, so we call this never dry chitin stock lah. So what we will do now is that we want to check the dry weight for this, and to do that we need to prepare all our all our petri dish in advance. So how we prepare this? First we need to weight this thing first, but before that, before we weight this thing, we must make sure all this thing is what we call homogeneously stir. Okay, at the beginning we measure the weight for this beaker. We also need to know how much actually we got now. We already homogeneously stir the thing for dry weight purpose, but before we take out some of the representative and put it into the petri dish, we want to weight the entire weight of this container in order to know how much chitin that we got from 200 gram of crab shell. So because we already tear this thing, so the value is 144 gram of wet chitin from crab shell. In order to measure the dry weight of this wet chitin, we must make sure we have all representative sample on this on this petri dish, glass petri dish, and then we dry it in the oven, and then after that we will weight that again, so that from that we can see the dry weight of this thing. So we make sure we sort of like ready with all the table here. So this is replicate A, B and C, and this is the empty beaker, and this is the empty plus the sample. And then after we put it in the oven for 1 hour, we take it out from the oven and weight again, and then we weight again for another 2 hours until the weight, the dry weight is stable. Only then we can do the calculation to find the dry weight for this sample. So first we take the petri dish. Okay, we need to make sure we jot down everything, and then we can put our chitin sample straight away. Okay, and then we jot down the value here, and then we repeat that for another 2 replicate there. After we get the wet weight for our sample, we will dry it in the oven. So we set this oven to 120 Celsius. Just the idea is just to evaporate all the water that is remaining inside this our sample. So we put it in the oven and let it dry for maybe 1 hour, and then after 1 hour we will check the weight again, and then if it's not, and then we repeat the drying for the 2nd hour until the weight of this be stable lah. As for the sample itself, we will store it in the fridge, and after we finish dry weight and so on, we will label this accordingly. This is our final extract of chitin from 200 gram of crab shell. So the texture for this is like a powder, but this is not dry. We keep it in never dry condition. So there are some water here. We believe the chitin, our sample here, chitin sample here, is not in nanofiber form, but because we keep it in never dry condition, it means that it's easy for us to turn this into nanofiber, even if we use the simple kitchen blending method. So if you have a high-speed kitchen blender, you can just subject this, put into water and blend it for about 10 minutes like that, and then you will get like a nanofiber dispersal of this chitin. But the width of that nanofiber may be around 100 to 200 nanometer of the width lah. If you want to go below that, let's say you want 20 nanometer or 50 nanometer width of nanofiber, then you need to subject the thing to this high pressure homogenizer or using grinding method lah. But having this in never dry condition allow us to easily repurpose this into suspension so that we can make a paper later on, and it make life easier and flexible. If you buy chitin from supplier, usually they come in flake or powder form, and normally that flake or powder they heat dry it. So when you heat dry a chitin, the fiber can honify. The honification is a concept of fiber make a hydrogen bond to another fiber, and because of that it hard to redisperse again in a suspension. So if you want to make a nanofiber from this, then you need to straight away go to high pressure homogenization or grinding. You cannot go with high speed kitchen blender, because it cannot it's not enough power to break this honified fiber. So if you want to characterize this stuff, what you can do is that you can take portion of it, freeze dry it, and then you subject it into any analytical instrument. For example, if you want to check the deacylation or acetylation degree of this chitin, you can use the FTIR spectroscopy. If you want to check the crystallinity for this, then you can use SRD. If you want to check the thermal properties of this, you can use a TGA. If you want to check the density, you can just use any density measurement tool, and so on. If you want to sort of like see the morphology of the fiber, what you can do is that you can take some of it, redisperse in the water, maybe blend a little bit so it's homogenized, and then put it on the sample holder and check it under electron microscope. If you want to see how strong is this stuff, then you can just redisperse it in the water, and then you can make a paper, and then you break it using a universal testing machine. So that's how you do it lah. So the final question, how much chitin in this container? So this, as we mentioned before, is not dry. So we measure the concentration for this. So the dry weight for this, what we call sample here, inside here, is 21%. And if we multiply that with the what we call with the total weight of this sample, we got around 30 grams of chitin. Meaning that from this 200 grams of crab shell, we managed to extract 30 grams of chitin. In other words, you get like 15% of chitin from crab shell lah. Meaning that you have crab shell, you have 15% of it is chitin. But remember, the percentage will be differ batch to batch, because if you use a different crab shell, some crab you have a thicker mineral, okay, compared to this crab have quite a little mineral, calcium carbonate, but some crab have thicker one lah. So if you have thicker mineral, then the amount of chitin relative to the total amount of the crab weight will be less lah. So you need to check batch by batch. So one last thing, it's important for you to store this, you need to label first. Label this stock, we call this stock chitin. Label it chitin from the crab shell, and also you put also the concentration. We said before this 21%, so you label also 21% concentration. Because why? Because it's easy for you to repurpose this thing into suspension or whatever lah. And also, it's important for you to write the date of extraction. Because remember, this is not dry. This is having water inside this, and water will invite microbes. And even though you put this thing in the fridge, then because there are water, there are risks of microorganism to grow within it. So we recommend to use it within 6 months of extraction lah. Of course, after 6 months, if there is no mold, then still okay lah. But to maintain reliability, we recommend to use this within the 6 months. And if let's say after 6 months, you still have some left over, you can use it for like simple and not like critical application, but maybe just do something else. But we recommend you to extract another batch of crab chitin to maintain the reliability purpose lah. So I think that's it for what we call for extracting chitin from the crab. So this method is versatile, meaning that you can use this method to extract any crustacean-based sample, for example, from shrimp, from prawn, from krill, or even from lobster. So all them is crustacean. So you can use the same extraction process to do that lah. So I think that's conclude this video. So hope you can learn something about how to extract chitin from crab.